But I've always felt that with all the research we're doing on mice, that they're like slowly becoming our overlords and stuff like that. But I was curious of the interventions that you're doing on mice. Could you talk more about the different strategies that you're going to be, the different therapies, and that you're going to be trying out with them?
Certainly, but yes, I grew up in the UK in the
Okay.
70s and 80s. I went to Cambridge, same as Douglas Adams. I'm a very big fan of The Hitchhiker's Guide to the Galaxy. Yeah, so I can only go into rather superficial description of this at the moment because we are still finalizing some of the details. But broadly speaking, there's going to be four therapies that we're going to be looking at. And as I say, all of them will be applied starting at 18 months of age. One of them is the gold standard at this point in terms of slowing aging down rather than damage repair. So this is a kind of control, really. And that's rapamycin, which has been used in a number of studies now, and definitely has, very reproducible positive effects even if you start late in life. Then the second one is a stem cell therapy. Here we're going to be using blood stem cells, which again, have shown if you take young, if you basically replace some of the blood stem cells in old mice with young ones, then they live longer. Then there's telomerase, which has been used in a few studies over the years, especially a rather high-profile recent one led by Liz Parrish and George Church, in which telomerase was supplied and caused a good life extension effect. And the last one will be a senolytic, and that's actually the one where we're still in the final stages of deciding which senolytic to use, but basically a drug that, or an intervention that selectively kills senescent cells. And again, we've had some lifespan data there. So we believe that given we're taking four things, all of which individually can extend lifespan in mice a little bit, even if you start in middle age, then putting them together, we've got a good chance of getting something. And of course, we've got different groups with different subsets of these four interventions. We've got one group that gets nothing, one group that gets all four, and eight other groups that get various combinations. So, yeah, we're quite excited.
That sounds very exciting too. Is
And I
there?
should probably say a little bit more about the study. So we were measuring longevity. That'll be the main readout. But of course, we also very much want to know about function. We want to know about health span. So
Mhm.
we'll be doing all the standard measures. There'll be some measures that we're doing which involve killing a small number of the mice at various time points to see how they were getting on, in various ways. And there are some other measures that are to do with, behavioral stuff or whatever that are not invasive, don't require killing the mice. So we've got a whole panel of those that we'll be doing at the same time. And my current intention is that we're going to be putting everything out on the web, like updated every week, telling everybody how things are going, because we're not constrained in the same way that most researchers are, either in academia where they have to have, terrible secrecy in order to be able to publish before anyone else does, or alternatively in industry where they need secrecy for, IP reasons. We don't have those problems.